We saw that when you're multiplying like bases, if I had 2 to the 5th times 2 to the 3rd, what did we do with the exponents? When we were multiplying, what did we do with the exponents? We added them together. 2 to the 5 plus 3, and that gave me 2 to the what? 8. Okay? But now we're going to look at the opposite. When you divide like bases, just like before, you keep the base the same, but now you're going to subtract the exponents downward. And this is important. We're subtracting downward. So if we have 2 to the 5th over 2 to the 3rd, you're going to subtract the exponents downward. And what that means is that you take the first exponent minus, or I should say the top exponent minus the bottom exponent. What would 5 minus 3 give us? What's 5 minus 3? 2. So it's essentially the exact opposite. When we multiply, we got to add them. When we divide, we got to subtract them. So 2 to the 5th over 2 to the 3rd, we subtract down 5 minus 3. Gives me 2 to the 2nd power. So that's the shortcut. That's the easy way to do it. You just subtract down. What we're technically doing here, or if we want to see what we're doing, we can expand this fraction out and cancel whatever terms we have in common. So let's look at my numerator. I've got 2 to the power of 5. How many times am I multiplying 2 by itself? 5 times. 2 times 2 times 2 times 2 times 2. It would be just like if we had 32. We ask ourselves what two numbers multiply and then spread it all out. What about the denominator? 2 to the 3rd power. How many times am I multiplying 2 by itself there? 3 times. 2 times 2 times 2. Now, is there any numbers in common on the top and bottom that I can cancel?
2.
A 2. Okay. So if I get rid of this pair of 2's, is there anything else I can cancel? Another pair of 2's. Is there anything else I can cancel? Another pair of 2's. Are there any more 2's on the bottom that I can cancel out? No. Boom, boom, boom. All we have left now is 2 times 2, which is 4. Right? But if we wanted to write this as an exponent, it would be 2 to the power of 2. Is there anything left on the bottom? No, except for a 1. Good. What is 2 squared, Nick? What did you say it was? 2 to the power of 2? 4. And it's exactly what we got by doing the quotient rule and just subtracting. So instead of doing all this expanding out and canceling and then applying those numbers together, we're making it nice and simple. You just take the top exponent minus the bottom exponent. So by expanding each of the 2's out in this fraction, canceling the 2's we have in common, we see how our shortcut called the quotient rule makes our work a lot easier. Does anyone remember what is a quotient? What is a quotient? The answer to a what type of problem? Exactly. Just like before. The product rule. What's a product? The answer to a what type of problem? Close. This little dot here. Multiplication, right? If you multiply two numbers, your answer is the product. If you divide two numbers, your answer is the quotient. All right? So if you see, again, take a look up here on the board, we have the same two things, 2 to the 5th and 2 to the 3rd. In one of them, we're clearly multiplying them, right? In one of them, we're clearly dividing them. So depending on what we're doing with our bases, that tells us what rule we're going to use. Whether we subtract the exponents or add the exponents together. All right? You always, always, always want to do the top exponent minus the bottom exponent. Subtracting downward. Top minus the bottom. So if I have this fraction here, x to the 3rd over x to the negative 5th, and I was going to subtract downward, I'd keep my base the same. What's the first number I'm going to put in this subtraction? 3. Minus what? Just 5? Negative 5. 3 minus negative 5. Well, now I've got two minuses. What do those two minus signs make when we put them together? A plus, a positive. So now, even though this is the quotient rule and we're subtracting, because we're subtracting a negative number, those two minus signs turn into a plus. Now we're just adding. What would my answer then be here? X to the power of what? 8. Great job. What about down here? I keep y the same. I know I'm going to subtract. What number is going to go first?
2.
Just negative 2. Good catch. Negative 2 minus what? 4. Negative 2 minus 4. What is negative 2 minus 4? Negative 6. Thank you. Is that my final answer? Y to the negative 6?
No.
No. We don't want to leave a negative exponent. Right? So there's 3 steps we got to do. What's the first step? Put it over 1. Okay. Now that it's over 1, what can I do? Flip it. Beautiful. Now that I flipped it, what can I do? Make it positive. So my final answer is 1 over y to the 6th. All right? Seems easy enough, right? Yeah, subtraction is typically a little bit harder, especially when we got these negatives and negatives, but hopefully that's not too bad. Let's take a look at some examples together. I'll write those two down, sir. You guys all got one? Okay. You guys got it all blue there?
Drop it in there. Oops, my bad.
Thank you. All right. So, in this first one, example number 11, we've got 5 to the power of 6 over 5 to the power of 4. What's my base here? 5. So I'm going to keep my base the same. What am I going to do with my exponents? You're going to add them? Well, if we're dividing, what do? We subtract them. So what are we going to put first, the 6 or the 4?
6.
6, why does the 6 go first?
Because it's on top.
Exactly. Top exponent minus bottom exponent. What is 6 minus 4?
2.
2. Okay, and what is 5 squared?
5.
5 times 5?
25.
25. We could do that one. That one's nice and easy. We get 25. Now, in example 12, what's my base in example 12?
2.
2. Very nice. I see that I'm dividing these bases.
So then you subtract.
So I subtract. What am I going to subtract from what?
Subtract 5 that's on the top.
Okay, so what's my exponent up here going to look like? Blank minus blank. What's it going to be?
5 minus 8.
Exactly. Top minus bottom. But what is 5 minus 8?
Negative 13.
Negative.
13.
Super close. If it was negative 5 minus 8, it'd be negative 13. 5 minus 8 is going to be negative just 3. Right, if you have $5 and then you spend 8, well, now you've got negative 3. You're in the red. You owe $3. Do we want to leave our answer as 2 to the negative third? No. So what can we do? Put a 1 on the bottom. Okay. What can we do next? Flip it. Now that we flipped it, what's my last step? Change it to a what? Exactly. 1 over 2 to the third. What is 2 to the third power? 2 times 2 times 2. What does that give me? 8. So my answer is 1/8. Now in example 13, I've got a base of x. My top exponent is 3, so I'm going to do 3 minus 1. Good. How did you know there's a little 1 there?
Because if there's no number on the bottom, then it's invisible 1.
Exactly. If there's no number on top of that base, it's an invisible 1. We have to factor that in. If I were to expand this out like we did on the previous page, x to the third over x. How can I expand out x to the third? What would that look like? X times x times x. The bottom is just going to be x. So what can I cancel from the top and the bottom?
X.
A pair of x's. What am I left with? 2 x's. So is that going to be what? 2x? No. Princess is saying no. What's it going to be instead? x with an exponent of
2.
2. There's 2 of them. Right? If I had x plus x, that's 2x. X times x, that's x squared. Very important we know the difference there. So if we expand it out, we see we end up with 2 x's. Over here, with the quotient rule, if we add that invisible 1 in, what does 3 minus 1 give me?
2.
2. Boom. Same thing. X to the power of 2. That's my answer. Got to be careful with 14 because of that negative. What's my base in number 14?
3.
3. Blank minus blank. What's it going to be?
We're going to
Subtract
subtract by 4.
by 4? What's going to go first?
4.
Negative 4,
Oh,
right? Minus what?
2.
2. So if we think about doing our little minus plus table, am I going to put 4 in the minus column or the plus column? Minus column. What about this 2?
In the positive column.
Well, what's in front of it?
Subtract.
I subtract. So we put that in the minus column too. So what's my total negative numbers here? 4 plus 2? 6. So we get 3 to the negative 6th. But I don't want to leave it like that, right? What can I do now?
Put a 1 on the bottom.
Put a 1 on the bottom, flip it around, and make it positive. We get 1 over 3 to the 6th. Now 3 times 3 times 3 times 3 times 3 times 3. You don't have to worry about doing all that. It's going to be too big of a number. So you can just leave it like that. 1 over 3 to the power of 6. Number 15, got a base of 10. I'm going to subtract.
First should be -3.
Good. Negative 3 minus what?
-7.
Negative 7. What happens when I have two minus signs together? Make a plus. So now I've got negative 3 plus 7. I'm going to do my plus minus table. Negative 3. Is that going to go under minus or plus? Minus. Plus 7. Is that going to go under minus or plus? The plus. Do I have more pluses or do I have more minuses?
It's equal.
I got more 3 and 7?
No.
I got more pluses, right? How many more pluses do I have than minuses?
4.
4. So my answer is positive 4. Negative 3 plus 7 is positive 4. And just a little trick to know, you don't necessarily have to do this, but if we have 10 raised to a number, that number tells me how many zeros go on the end. For example, if you have 10 squared, what is 10 squared equal to?
100.
100. How many zeros do you see in 100?
2.
2 of them. Look at that. 10 to the third power is 1,000. 3 zeros from that 3 on the bottom. So what's 10 to the fourth power going to be?
10,000.
10,000. Exactly. To 1 with 4 zeros. You writing this down?
Yeah.
Okay. Last but not least, number 16. Base is 7. What's going to be the first number I write?
0.
0, nice. Minus what?
6. -6.
Negative 6. two minus signs next to each other make it what?
Positive.
Positive. And what's 0 plus 6? 6. That number's going to be way too big. We're not going to worry about expanding that out. We'll just leave it as 7 to the power of 6. Okay. Any questions we can answer about that? Okay.